Hey everybody, I'm MS Farzan, and welcome to this video series on learning C# and Unity for digital tabletop game development. In this series, I'm going to introduce you to the basics of C# programming using Unity, although a lot of the concepts we're going to learn will be applicable in other programming languages as well, and game development in general. Throughout this series, I'll be providing an emphasis on learning Unity for digital tabletop game development, which should be useful for anyone who wants to learn to code in C# or work with Unity. After learning some C# and getting comfortable with the Unity editor, along with some practice projects and outside learning of your own, you'll be able to run simulations, make your own games, and begin exploring the wider Unity ecosystem for supplemental skills and projects. If you're not specifically interested in digital tabletop game development, you'll probably still find this series to be helpful, as we'll be learning core concepts that are central to C# coding and Unity game development that you'll be able to apply to other programming languages and engines. And I'm a big proponent of using digital tabletop games in learning to code, because we're able to work on a lot of the logic that goes into digitizing those types of games without having to dive into stuff like physics, vector math, animation, and that sort of thing. What the heck, maybe we'll explore those later in other videos as well. There are a couple of caveats before we begin. First, this video series is meant to be supplemental to your own learning process, rather than attempting to replace the thousands of hours of free and paid tutorial content out there. I'll suggest practice projects for you to tackle on your own, and highly recommend that you spend some time every week in addition to these tutorials to pursue a wider curriculum in C# development. If you don't know where to start, I'd suggest trying your hand at the tutorials at learn.unity.com to polish your skills and learn other core concepts. One final note. I won't suggest that C# is the best first programming language to learn for game development, or that Unity is the best engine for making games. C# can be a little daunting towards newcomers, and the Unity editor can sometimes be cumbersome when you're trying to learn how to do simple things. Conversely, however, there are a ton of resources out there that can help you solve problems if you get stuck, and the workflow in Unity, while not always intuitive, is certainly a learnable skill with some practice. Once you've learned the basics, you can eventually make pretty much any type of game, which is pretty cool. Importantly, Unity is one of the game engines that I'm most comfortable with, and it's helped me learn other game engines and polish my C# skills too. Okay, with all of that out of the way, let's get started. The first thing we're going to do is make sure that we have our game editor set up and we understand what the Unity ecosystem looks like in general. As you can see here, I have a couple of things open. The first one is called Unity Hub, and in the background I have a code editor called Visual Studio. I'll talk a little bit about each one. The things you're going to need to do to get started are to install Unity and also Visual Studio. If I go to the Unity website, just unity.com, you'll see this big blue button that says Get Started up in the corner. And you'll have to determine what kind of plan or pricing you want to do. My recommendation would be for a beginner or someone who's just learning to code or tinkering around with the editor, just go to the individual tab and choose the personal version of Unity, which you can use for free. And as you see, you're eligible to use it if your revenue for your business, I'm presuming that you don't actually have a business right now, but maybe if you do, if your revenue or your funding is less than $100,000 in the last 12 months, you can use the free editor. There are some stipulations for what comes with the free editor. We won't be talking about that right now. I just think it's the easiest way to get up and running. When you click Get Started, you have to jump through a few hoops to determine, are you a first-time user or a returning user? If you are a first-time user, you'll have to, agree to the terms and go ahead and download it. And it will download Unity Hub, which is can be a little bit confusing if you're just trying to use the Unity editor and then you have to download this Unity Hub and you're like, what do I need all this for? Unity Hub is basically a solution so that people who have multiple projects and multiple versions of Unity can organize them based on their versions of Unity. As you can see, I have the Unity version 2019.2.15 F1 that I'm using for all of my projects. If I had other versions of Unity, I could select them when I'm working on a project, because sometimes when you are working in a certain version of Unity and then you transfer over to another version of Unity, it might break your project. So you want to make sure in the first step to choose a version of Unity that you want to use and stick to it when you're working on a specific project, as that will help save you from tearing your hair out later when Unity does an update and it may not jive with the project that you're currently working on. Once you've installed the Unity Hub, you're going to be looking at this scene. You probably won't have anything in this window, whereas I have a bunch of projects that I'm working on. And I'm just going to say, I'm going to click on New, and I'm going to create a new project. In this window, I see there's a lot of different options for me to create my project with, and I'm going to click on the 2D version of this project, because everything we're going to do in this tutorial series is working with 2D elements within the Unity editor. Unity, as I'm sure you're familiar with, is a game engine that allows you to make 2D and also 3D games using their own proprietary editor and C# programming. And the workflow is actually pretty similar for both 2D and 3D games, but there are some core differences in the way that we're going to do things that we really don't need to work with any of the 3D tooling. So we're going to choose 2D as a template here. You can choose a name for your project. We're just going to call this Tutorial Series, and choose the location where you want to save your project in, and hit Create. And it's going to create a new project for you. And if you're using a different version of Unity than I am, it really won't make that much of a difference. There are some small things between versions that can change and might be a little bit different, but by and large things will be the same, unless you're using a very old and outdated version of Unity where it might look very different with what I'm about to do. But by and large, if you're using a more modern or current version of Unity, it'll be similar to what I'm doing here. Okay, so we're looking at the Unity editor, and there are obviously a lot of things on this screen that you might not be familiar with, so we're going to go through each one of them in turn. And our goal for this particular first video is just to get comfortable with the Unity editor and writing scripts and getting to log to what's called the console. We're going to write things to the console, which is actually open right now in my screen. Like I said, things might look a little bit different in your scene than what I'm looking at here, but by and large things will be mostly the same. And you can drag a lot of this stuff around if you don't like this section on the right to be on the right and you want it to be on the left, or if you want to move things around, you can absolutely do that. Just remember that I'll be looking at this scene pretty much the way that we're looking at it right now for the rest of this tutorial series. The other thing you'll want to make sure that you have installed is called Visual Studio. You might, if you're familiar with coding, you probably are already familiar with what a code editor is. It's basically a place where you can write a bunch of code and save it, and it highlights things for you, and sometimes it serves as what's called an integrated development environment, and we'll talk about all of those things in turn. I just want to make sure that you have installed Visual Studio, the Visual Studio tools specifically for Unity. For example, when I look at my Visual Studio window here, which is where we're going to do all of our writing of all of our code, I want to make sure that I go up to Tools, and I go to Get Tools and Features, and you might have already done this in your installation. And when I go here, I want to make sure that I've installed the Unity toolkit for game development. It's called Game Development with Unity. And when you have that, make sure that you have that clicked. If I looked at that in the individual components area, and I just search for Unity, you'll see that it installs the Unity 2019.2 64-bit editor and Visual Studio tools for Unity. And when I just hover over this, you'll see Visual Studio extension natively supported by Unity for developing cross-platform games with Unity and Visual Studio. That's kind of a long and circular way of saying that this will help us in our Unity code development. And we'll see exactly how that works in our videos and what it does to help us. But essentially, to work in Unity, not only do I need Unity itself, the editor, to drag and drop things across the screen and make my game scene, but if I'm going to write scripts so that I can add to the functionality of my game, I'm going to need a code editor like Visual Studio. And as you see, I have Visual Studio Community 2019 installed, which and the version I'm using is 16.4.0. Apparently I need to update. So what can you do? Okay, so we've got this stuff installed. Let's take a look at what the Unity editor looks like so that we're comfortable with it as we begin to start our journey in making games and learning about C# programming. The Unity editor is split up into several different components, only some of which are available on the screen at this time. The first thing that your eye will be drawn to, or at least my eye is on the left-hand side of the screen, there's something called a hierarchy that its parent, or the top of the hierarchy, is called sample scene. In Unity, the scenes are a very important concept to remember as a container for everything that's going to happen in a part of your game. So a scene could be like my title screen for my game, where I'm able to have like a start menu that allows me to start playing the game. Or it could be one world within my 2D platformer game, or within my, my 2D card game. Or it could be the pause screen. And it's a way for me to collect all of the different objects that are in a particular screen, like all of my cards, or all of my enemies, or all of my tokens for a card game or a board game that are existing in one world or one area of the game. That's why it's called a scene. This one's just called sample scene because I haven't given it a name. And what it also has is a main camera, which we won't be dealing with too much because as a 2D tabletop series, we don't really have to do much with wondering what the camera's doing at specific points in time, like you would with an over-the-shoulder like 3D game or even a platformer. We will have to deal with it a little bit, but not too much, so I wouldn't worry about it. All I want you to know is that in your hierarchy, that's where you're going to see everything that's in your game. Like if I have a card in this in my game, or if I have a token in my game, or if I have a game board or a background. When those things are active, they're going to show up in this hierarchy on the left side of the screen. Often they're called game objects. Objects, the term objects is an important term that we'll encounter again and again, and a game object is anything that I have in my scene in this hierarchy. Sometimes, like I wouldn't call the main camera actually a game object, but sometimes things that don't seem like game objects will actually be treated like game objects in Unity programming. We'll encounter that as well. Moving from left to right, I suppose kind of clockwise, we look at this scene right here. This is what's going on in my game. So if I had anything in my game, it would appear here. And if I had a game board or cards out on the screen, or if I were making a platform or something, this is where I'd view a preview of what's going on with my game, particularly if I hit the play button. When I hit the play button, then you can't see anything right now, but that means that my game is running and I'm able to preview the functionality of it before building it and sending it out to the world. We'll use that a lot. There are some options here like where do you want to display the game, what's the resolution going to be, the scale of in terms of zooming in on the game. We're not going to be using these right now, so we don't need to talk about them. But we do want to click over from the Game tab to the Scene tab. And this is where we'll be doing most of our work in terms of the user interface for the game. So when we want to put a card down on a background on the screen, or we want to put cards on the screen or tokens or what have you, we'll actually place them here in this scene view of the game. Sometimes we'll do it through code, but other times, like if we have static stuff that we just want to be on the screen, we're going to drag and drop them over here, almost like if we're using Photoshop or another editor, and we'll see that in play. Just remember that these two tabs are very important. The scene is where we do our work, and the game tab is where we view our work and preview it. If you want to check out the Unity Asset Store, like you want to download images that you can use in your game, or if you want to use templates or add-ons, that sort of thing, that's where you would do this. We might encounter this later in our video series, but we won't be working with it now. And we certainly won't be dealing with the animator right now, but that's definitely something for us to look into at another time. Continuing on to the right side of the screen, we have the inspector, which is something that's useful when I click on something that's in my hierarchy here. It brings up a bunch of information in the inspector about that game object or the item within my hierarchy. So as we see with the main camera and with most game objects, even just a game object that does nothing, we'll have a transform, which essentially means the location of the object and its scale and rotation. So I'll be looking at my If I had a card as a game object, for example, I could move it around either here on the in the scene area, or I could change its X and Y coordinates or the Z coordinates. With a 2D game, of course, we're working with a plane that just has 2 dimensions, X and Y, so we won't be using the Z coordinate very much at all, which is used mostly for 3D game development. If it has some rotation, or if I want to change the scale, I can do that here in the inspector. And then there are specific things that are evident here in the inspector that will change based on the type of game object that we're inspecting. For example, the camera has a bunch of options here based on what kind of camera we want to use, what we want to do with that camera, and this will vary based on what we're doing with the game object. The important thing to notice is that each of these things attached to this game object, this main camera, that's called a component. And we can click this Add Component button and get a bunch of options that we're able to add to a particular game object, and that's going to affect its functionality. We'll be getting right into this very soon. Just know that when you click on a game object in the hierarchy, you'll see more information about it in the inspector, and then we can add components to it as we need. Down here at the bottom, there's a thing called the console and also the project. I'm going to talk about the project tab first. At a very basic level, what we have in the Unity editor is a folder called Assets, in which we only have a folder here that's called a subfolder called Scenes, and that's where this sample scene lives. The project folder is just a way of us organizing the different elements of our project as we see fit. You'll see me do it a certain way. For example, I'll keep this scenes folder, but I'll also create a scripts folder that I'm going to bundle all of our scripts in, and other folders as well, just to keep our project organized and sensible so that I know where everything lives. You can treat this as you like. It essentially acts as a file system for us, and whenever we need to access something, we can come down here and just grab it. If I move over to the console window, the console is a really useful tool and something that I encourage you to make your best friend. For a programmer, the console is very important in displaying information about what's happening in our game and in our code. Often we'll do things called logging to the console, basically just writing a message to the console to make sure that things are working. Other times, we'll look to the console if there's an error, and Unity has a fairly substantive error debugging system where it will log errors to the console and let us know when something's not working the way that it should. So it's a very important area to become comfortable with, and it leads us into a just brief overview of what is an integrated development environment. When you're programming, usually you need a lot of tools to help you to develop. You'll need a code editor, you'll need what's called a command line interface, or a way to run commands. You might need some version control system so that multiple people can be working on a project at the same time. We'll talk about each one of those things in turn, but all I want you to know right now is that for our purposes here in this video series, the Unity editor as well as Visual Studio comprise our integrated development environment. We really don't need anything else to make our games at this point. We might need to add a version control system. We'll talk about that later in another video in this series. But we have everything we need at our fingertips to start making games right now, once you have Unity and Visual Studio installed. So with that being said, let's just take 2 seconds to look up here at this top level menu. You'll see a lot of different things that will look scary when you look at this menu. Like when I go to File, I have pretty easy stuff like new scene, or if I want to open a scene or a new project. I have build settings when I want to build and run my game. When I go into my edit menu, then there's a lot more stuff. Like if I go down, I see project settings and preferences, and I might not know the differences between those two, and we'll get into that at some point. When I go to my assets menu, we're going to be using this when we want to create a new asset, or if we want to create new game objects, we might go up to the game object menu. And I just want to expose you to a few of these things over time, because it can be overwhelming if you're trying to look for, like, how do I create a new game object, or how do I change certain preferences for my game. I think it'll be a little overwhelming if we look at that right now. So we're going to look at each one of those in turn when we need them as appropriate throughout the video series. Okay, cool. So let's do a thing. Let's start by right-clicking in our hierarchy, and let's say create empty. We've created an empty game object in the hierarchy. You could also go up to the game object menu, and you could click create empty, and we would do the same thing, and that would create us create an empty game object for us in the hierarchy. That doesn't really do much for us right now, and to be honest, we really don't need it to. We just need something that we can work with and attach code scripts to. So I've created 2 game objects. All I have to do if I don't need that is just click on it and highlight it and just hit delete, and that's fine. Or I could, of course, just right-click it and hit delete. You'll have to determine what workflow works best for you. And you'll notice that as I've done created a game object here, the sample scene item in the hierarchy has an asterisk next to it. That just means that something's changed in it, and it lets me know that I've done something. And if I want to make that go away, I can click Control S, or go up here and just say File, Save, and then it will save the scene. And then now I know that the scene that I'm working with has already been saved. It's just a little notification for you. I'm going to click on this game object and see that it doesn't really have anything in it. It just has a transform, and the position is at what's called the origin. When you have a transform, or the location of the game object is at X and Y coordinates of 0, 0, that's called the origin. It just means like it's right at the very beginning of the world where things are meant to begin. We don't really have a physical representation of this game object on my screen, and that's fine. We don't really need one. I'm just going to say here on the right side of the screen, add component, and right at the very bottom of this drop-down list is something called new script. I'm going to click on that, and it autofills a name for it, which is called new behavior script. I'm going to change this to something like debug script. You'll notice that there's the casing matters, or how I capitalize things matters, and that often depends on programming languages themselves. Sometimes you'll have what's called camel case, which is when you have a, like if I have a lowercase letter that begins my word, and then I'll have a uppercase beginning of the next word. So you can kind of see that I have a lowercase debug and a higher case script. That's called camel case. In other programming language, you'll have what's called snake case, which is debug _ script, something like that. We're not going to talk too much about that, but I just want you to know that naming conventions do matter in the way that you name things. So here, I'm just going to write debug script both with uppercase, and I'm going to say create and add. And Unity is going to do a little bit work in the background to do that for me, and then it creates this debug script that I've named. I might say, okay, how do I access this script? What does it do? Where do I find it? Ordinarily, when you create a script, well, I should say, when you ask Unity to create a script, it creates it in your top-level assets directory right here. You can see that's my debug script in C#. I'm going to right-click here and say Create Folder, and just call this folder Scripts, and drag and drop this debug script into the Scripts folder, and there it is right there. So now it feels a bit organized. If I wanted to, I could have said Create C# script, and then call that debug script. It won't allow me to right now because you can't have 2 scripts with the same name. So just call this debug script 2, And if I wanted to, I could click on my game object and drag and drop this right to this area where you can see it highlights in blue, and then I add it as a new component. I could do that as well. Either of those workflows will work. I don't need this, so I'll right-click this component and just say remove component. And then back in my project tab, I'll click on the debug script and delete it. I don't need it. Cool. So when I click on this debug script, I get in the hierarchy some information about what's going on in this script. This is actually a preview of what is happening in the script. And sometimes if you just need to check in on a script and make sure that you've done something right or remember what the functionality is, you can just look at it this way. Other times, and most of the time, you'll double click on the script and it will open Visual Studio. And what's cool about Visual Studio is that the workflow that we installed, or the workload that we installed with Unity, will actually help us with our programming and give us helpful tool tips and let us know when things aren't working as they should. And welcome to C# programming. This is your life now. This is what things are going to look like whenever you do any Unity scripting in Visual Studio. Let's step back just for a moment and look at this from a wide-angle lens. What do scripts do? Why do we use scripts in Unity? Well, let's say I'm in my my game window, my scene, and I add a bunch of cards to it because I'm making a card game, or I add a bunch of tokens because I'm making a board game, and it looks really nice, and I have this like really beautiful game that has all my cards on it, and it looks like it's ready to go. Well, how do we actually add functionality to that game? How do we say that this is a game object you should be able to drag and drop across the screen? How do we say that this token is worth 5 gold, but this other token is worth 10 gold? How do we say that it's my turn when I start the game, but then it's your turn, and then we move counterclockwise to determine whose turn it is? That's what we need scripts for. We need scripts to tie all of these empty game objects together and make logic for our game that incorporates a lot of things that Unity is able to provide for us, like animation or drag and drop functionality or other things that we might need in our games, as well as the specific game logic that we have for our games. So my game might be have very different game logic from your game, and Unity's not going to know any of that unless we write scripts that allow us to digitize the functionality that exists in our tabletop games or in any type of game. So if I'm making a platformer, for example, I need to tell Unity what the physics looks like in that game. I need to tell Unity what happens when I jump, what happens when I shoot my weapon or my wand, or what happens when I duck or get hit by an enemy. That's what scripts are going to handle for us. And Unity uses C# as its scripting language to handle all that for us. If you're not familiar with C#, no problem. We'll deal with it in this video series. Just know that it's what's called an object-oriented programming language, and I think that will be my first assignment for you in terms of homework, is to look into C# in general and just become familiar with some of the basic foundational concepts in C# programming. We're going to deal with a lot of them here in this video series, and C# is a more general purpose programming language that is used for many more things than just programming games. You can make apps with it, you can do web programming with it, you can make mobile apps, like you can do a bunch of stuff with C#, and it's fully supported by Microsoft. And there's so much stuff that you can do with it, so much out there, that it would be a disservice for me to say that, hey, you'll be a C# pro just by watching this video series. Certainly, you'll learn how to use Unity and C# for Unity in this video series, but there's a lot more to learn when it comes to object-oriented programming. And while I think that Unity is a great place to learn a lot of those concepts, there's so many more applications out there for C# programming that I really think you'll benefit from taking a look at what it can be used for. Let's look at this basic template code that is developed for us every time that we create a script. We'll see at the very top 3 using statements, The first one saying it's using system.collections, using system.collections.generic, and using Unity engine. We don't need to know too much about this right now, other than these are called namespaces. If I want to do anything in Unity, I need to refer to the Unity engine in this namespace and say, hey, everything, all the code that you have or that supports Unity programming, I want to import that into my project so that I can use it and make my development process easier, so I don't have to start from scratch every time. We don't need to deal with namespaces right now for our purposes, so we're just going to leave those alone. Further down the line here, as you see that I have on the left side of my screen, I have all these numbers for my lines, so I'm going to refer to them in our tutorials. On line 5, I see that there is what's called a declaration of a public class debug script, which is the name of our script, and I see this little colon here, and after it says monobehavior. What's really cool with the Visual Studio tools, the workload that we have installed for Unity, is when I hover over something, it gives me a little bit of information about what that thing is. So when I hover over our debug script, it shows us that, well, we created a script, but really, in actuality, that script is a C# class. It's a little bit early for us to talk about what a class is. Let's just think of it right now as a container for a bunch of code that we're going to be writing. Much more complex than that, but we'll get to that later on in another video. We just see that it's called, what we've created is a class called debug script. And that's public, so that just means that we can use it anywhere in our scene. And this little colon means that this script derives from something called monobehavior. When I hover over this, I get a tooltip that it says class Unity engine.monobehavior. Monobehavior is the base class from which every Unity script derives. What we need to take from this is just to know that this class debug script, this script that we've created, it derives from, or it inherits from another class that Unity has created for us, meaning that we're not coding in a vacuum. We're importing a bunch of stuff, a bunch of functionality that's working under the hood for us, so that when we start programming for Unity, Unity will know what we're asking for it to do. There's a lot of stuff working behind the scenes that allows us to do what we're going to do here, and the way that we're able to do that is to derive from a base class that Unity provides for us. Pretty much anything that happens between these two curly braces is the code that's we're gonna put into this class or into this script. So we don't need to worry about anything outside of it right now. Inside of it, there's this base template, which is it has two things in here. It has something that's called void start and void update. When I mouse over start, it says Unity start is called just before any of the update messages is called in the first the first time. Basically, start is something is what's called a function or a method. We'll talk about those later, where I can include code that I want to happen at the very beginning of the life cycle of a game object. So when a game object is put into my scene and the game starts, then I want something to happen. I'm going to put it in between these two curly braces of the start method or function. Whereas update, it says update is called once per frame. If I mouse over that, it says update is called every frame. If the mono behavior is enabled, the Unity message update is empty. Great, thanks for that information, Unity. That just means if I need something to happen every frame or every tick of the game or every second or millisecond, however you want to think about it, I would have it happen within these two curly braces under these words void update. So like if you've heard frame rate being 30 frames per second, that just means that Unity is going to be displaying 30 frames of my game per second. And if I wanted something to happen every frame, I would put it within this update method or function. Before we unpack what a method or a function is, let's just kind of look at what the functionality of these two things are. So because you'll remember this is attached to my game object, my empty game object just here, which is in my scene, that means that anything that I do in the script is going to affect the functionality of this game object. So in my within these curly braces under the start function or method, I'm going to call debug.log and then have an empty parentheses just right after it. There's a few things that I want you to know about this. When I write debug.log, what's going to happen is I'm letting Unity know that I want it to log or write something to the console here in this tab. And I want it to say something. And that will depend on the use case scenario that I have for whatever is happening. There's a few things that I want you to know about this. First, the punctuation and the capitalization matters. For example, if I say debug lowercase, I will get a squiggly red line underneath it, which if I mouse over it, it will say the name debug does not exist in the current context, meaning that Unity doesn't know what I mean by debug. It's expecting me to have an uppercase D so that it says debug.log both have uppercase letters that begin the words, and there's a dot in between them. So I couldn't say like dbu.g log or something. The punctuation and also the capitalization matter. And if I hover over this, it says it's a class containing methods to ease debugging while developing a game. How helpful, thank you. But I see a squiggly line under this log thing, and it'll say logs a message to the Unity console, but there's no overload method. Log takes 0 arguments. That is a long way of saying that I haven't told it to log anything, and Unity doesn't like that. So within these parentheses, I'm going to put a quotation mark, and I'm going to say hello world, and I'm going to end that with another quotation mark. And all of this in between these two parentheses, that's called an argument. I'm inserting, or I'm passing an argument into this debug.log message and ending everything with a semicolon. When you have a semicolon at the end of a code block or at the end of a line, that just means like, okay, that's what I wanted you to do. That part of the script is finished. And we always need to finish our code with a semicolon in C#. Like if I delete this and then do something else, you'll see that things are a little bit wonky, and it will say, if you mouse over this little red squiggly line, we've expected a semicolon. So you're going to want to make sure to keep your semicolons where they need to be. So I say debug log hello world. I save my script. I can save my scene too. I'm just going to hit play. And I see here in the console a timestamp, and it says hello world. And if I were just in my project pane, I'd see the most recent message here down at the bottom that says hello world. That just means that I've done it right, and yeah, my debug logger is working. Let's dissect that just a little bit so that we understand the functionality behind it, as I think it's very important to understand how things work and why they do to understand how to better implement them in the future. So what's happening here is that we're doing what's called calling a function or calling a method. A function is a way of containing a bunch of functionality that we want and using it over and over again. Debug.log is one of those functions, or they're also called methods in some cases, and I'll be using those terms pretty much interchangeably until we get to a point where we understand exactly what is the difference between them. But I'm calling a function called debug.log, which is a function that Unity provides for us. It says, okay, when I receive this name, debug.log, that means I need to print whatever's in between the parentheses in this console. That's what Unity knows how to do. And we're passing into an argument, which is whatever happens between these parentheses, that is simply as we hover over it, it's called a string. A string is anything between quotation marks that is comprised of letters or words. So if I wanted to change this, and I'll say hello Unity, that's a different string than hello world would be. And we'll be dealing with strings quite a bit. It's just a particular data type that we'll discuss in more depth at a later time. But we kind of need to know a little bit about it just to understand how this is working. When I call this debug log function, it sends a message to the Unity editor that I want to write something to the console. And the important thing is that when I save it, Unity in the background does something called compiling it. We don't really have the scope to talk about compilers or compilation in this video series, but it's something that I encourage you looking into because it's important to know the difference between compiled and interpreted languages. Just suffice it to say that C# is a compiled language, which means that before it runs a script for you, it has to do some work in the back end to compile that script and make it ready for its functionality. Other programming languages like Python or JavaScript don't require compilers in the same way. They might be interpreted, and that means that you can just run things right after you write them. There might be a pause between when you save a script and when you can actually run it, or if you've done something incorrect in your script, it might be caught by the compiler and you'll get an error message that doesn't allow you to proceed. That's what's happening behind the scenes before we're able to actually use the script in our scene. Okay, I'm off my soapbox and we're going to talk about what the update method does. When I go into this, in between these curly braces for the update method, you recall this does this, it calls whatever's within it once per frame. So if I say debug.log hello world in the update method, and I save it, and then I hit play, if I look in the console, it says hello Unity, and I only see hello world appear once, but I'm seeing it's calling this so many times. It's only called hello Unity once, which is called in my start method. And then in hello world, it's called now 2,500, moving on 3,000 times. If you wanted to see each one of those times that it's being called, you could say this little button up here that says collapse, unclick that, and you'll see that now it's logged every single time that it said hello world here in my console. But when I hit collapse, then it just folds that all into one, and we called it 3,300 times. So that's what the start and the update function do for us. Great. So I think that's pretty good in terms of what we're looking at for the very beginning in setting up and learning how to log to the console for this video. Remember to I think between this video and the next, it would be good even if you just go on Wikipedia or do a Google search for object-oriented programming, C# programming, and compiling or compiled versus interpreted languages. I think that's a good amount of homework. You could also try debugging things to the console. You know, add another thing here that's called debug.log hello, and then enter your name here. Or doing that in the update method. It would be helpful also just to look at well, what the heck? Look up methods and functions and the arguments, or calling a function and function arguments, just to kind of like prime yourself for some of the things we'll be doing in the next video. And I think if you take this one bit at a time and really appreciate all of the different things that we're doing specific to your own development process. So it's great if you follow along with me, but take some time afterwards and do something that feels personal to you, that even if it's just, you know, changing the words that we're using or doing a little research that is specific to the type of game that you want to make, that's going to be the way to be really successful in your Unity development as a developer, so to speak. So next time we'll pick up with looking at debugging more to the console and working with what are called variables and data types. And we'll continue our adventure in this series about learning to program in C# using Unity for tabletop game development. I hope this video is helpful for you, and if it is, please like it and subscribe to my channel. If you want to do me a solid, please feel free to check out my games, and better yet, check out my games and books and tell someone about them. I'm really excited about Entromancy, which is a series of my role-playing games and card games and novels, and I'd love to get the word out about them, so I'll include more information about them in the description for this video, and we'll see you next time.